Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello, everybody. Thank you for joining another episode of Lunch with Tech Leaders. Today, I have a guest with me to discuss Git and version control, and that guest is Shereef. So Shereef is a staff software engineer at DaySmart Software and is also active in the Google Developer Group in Halifax, Nova Scotia. So Shereef, hi. Thank you for joining us.
You are very welcome. Excited to be here. Thank you for having me.
Yeah, well, thanks, Shereef. Is there anything else you want to share about yourself before we get started?
I've been working with Git even before I graduated. I was working with open source, and it really built me up with Git. I used to contribute to an open source game in 2009. And so I've been using it for quite a bit, and I've been in many sticky situations that gave me a lot of experience. So I'm happy to share it with everyone.
Great, thanks, Shereef. So we're gonna talk about a lot of basics, also some advanced topics as well. But we're kind of hoping that everybody will get a little bit out of this discussion. So first off, for developers that are completely new to Git and the concept of version control, can you explain a little bit about what it is and how developers use it in their daily work?
Yeah, so basically, think of it as a database for your code, but instead of always having all the code, it saves differentials between the first commit and the next commit and the next commit. And you always want to have that history handy in case you introduced a bug or in case you want to deploy a specific version. And it really helps you have that data when you need it the most.
What do you think, things would look like if developers did not have version control?
So Git really shines in helping people collaborate. And before Git, it was really messy. Like you'd have to zip the code up or something and then push it to the server and maybe build it on the server. And then you get to zip the build code and then deploy it somewhere. It was a mess, but right now people can collaborate really easily. They can make sure that the correct version is being deployed, and whenever you really want to be at that code, you can check out the specific branch or specific hash that you want to build at and deploy it. And it really streamlines the process and helps people collaborate and make sure that they're getting exactly what they expect. In the past, I have missed folders while trying to zip something to get it somewhere, but in version control, that never happens because everything you intend to have will be there.
Cool. So obviously a big part of, Git, you mentioned that it's, it's storage of your code, and with that is commit messages, and that's can be part of your documentation. So what qualities do you think make up good commit messages?
So commit messages are consisting of a couple of parts. There's the summary, which is the first line, and there's the description, which basically anything after the first line and before the last line, and the last line is called the footer. Now, you definitely want a very short summary that's clear, concise, and descriptive. And then in the description, you want to have all the relevant details that's going to help anyone understand what this commit is doing exactly. And then in the footer, maybe you can add some details like what breaking changes did you introduce. If you haven't introduced breaking changes, you can leave the footer empty, and so on and so forth. And I know that commit messages in some repositories and some companies are being used to actually build release notes. So That's why the summary needs to be clear and concise and descriptive. It should also mention what changed and why.
Cool. And then, of course, another big part of version control is branching strategies. And there's been a lot over time about, trunk-based development and other feature branching strategies. Can you explain, a little bit more about what some of those are and which one is your favorite?
Yeah, sure. So I'm going to talk about three of the most famous branching strategies. There are a lot more out there, but basically the most famous one are feature branching. And basically what it is each feature is developed in its own branch and merged back into the main branch once it's complete. And then there is the Git flow. The Git flow is a more complex strategy with multiple branches. So there's a develop branch, which all the features go into and you branch out of it. And then there's a feature branch that you need to have for each feature. And then there's the release branch where when you want to release something, you create a branch from that, from that commit hash that you want to release. And then the hotfix usually comes from the latest release, and you can fix something that you broke in your last release. And my favorite is the GitHub flow one. It's very simple. It's very similar to the feature branching. So what usually happens is that you still have the main branch that you have everything merged from and you release from. And then when you go out to make a new feature, you create a branch from this feature, you do all your work in that branch, and then you create a pull request. When you create a pull request, your peers can review that and make sure that everything's fine. And of course, before you give it to your peers to review, you need to review it yourself. And then tests get ran, and then you can merge that pull request and make sure that everything is very well working very well. And then it goes back into the main branch, and everything is working great.
Excellent. So there's various GUIs for Git, such as Git Kraken, Tortoise Git, Source Tree, that are popular. And of course, many people more experienced with Git use exclusively the CLI. Do you find those tools beneficial? Do you think that people should learn to use the CLI and focus on that? What I guess what would be your advice to users of Git and how they might use those tools?
Let me tell you about my journey and what I started with, and then I'll give you my recommendations. So when I started out, I was a noob developer, and I wasn't even a developer. I was like playing a game, and then the game had a bug that I wanted to fix. I went to their chat, and so I did not know Git. I did not know the commands. So a GUI was essential for me because I definitely was not equipped to handle the CLI. And at the time, I had no command line knowledge at all. So I was like really a noob. So I definitely recommend everyone to check out a GUI. My first one was Tortoise Git. Now, the thing that's beautiful about Tortoise Git is that, like Source Tree and some other GUIs, it gives you the commands it's running on every step. You want to commit? Great. A window pops up. It helps you select the files. And then when you hit commit, it gives you that command that it ran. So even though I did not know the commands and I did not research them, I always had them in front of me. So at any time, I knew what was going on in the background. And that helped me like connect the dots between what the GUI is doing and what Git is actually doing in the background. Now, fast forward to a few years later, I'm having all kinds of trouble because I misused Git, and now I need to actually use the command line. Now I'm reading articles and trying to find out how to fix the mess that I created, but the commands aren't strange commands to me because I've already seen them many times while using Tortoise Git. So my advice basically, yes, use a GUI, but you should know what the GUI is doing in the background. My current favorite uh, setup is using VS Code for everything. It has on the left the Git or the source control tab, where you can make commits and amend them and do whatever you want, and then you can do it in the terminal. But the problem with VS Code is that it doesn't show you the commands it's executing unless you go to the output tab and show the Git from the dropdown, choose Git from the dropdown. And it's a little bit too verbose. So I wouldn't recommend that for someone that's just starting out, but definitely the GitHub plugin for VS Code, the GitHub pull request plugin for VS Code streamlines everything. If you're using GitHub and using VS Code, that's going to be amazing, but don't start with that. Start with something that shows you the commands.
That's super interesting, that the idea of allowing the tool to output the CLI commands and learning that way. That's interesting. Now, as far as I know that you have experience migrating Git repositories to another provider, let's say Bitbucket to GitHub, or maybe you're going GitHub to GitLab. Can you talk a little bit about best practices for that and some of the advice you might give to folks that undertake something like that?
Of course, yeah. So the first thing you want to do is you want to make sure that you know all the references to get your Git repository, because you definitely do not want to be surprised after you've done the migration that something broke. So put a research task or a spike on your sprint and try to research all these links and list them out, make a document, and then always communicate very well with your team. Let them know this change is coming. Let them know it's not going to affect them. And the only change that they'll have to worry about is that they're going to change the link to the repository when the time comes. And probably schedule some time to do this a little bit after hours so that no one is working at the same time you're working. And then when you're ready to start, the first step is always make the source repository read-only. You can do that by taking away all write access to the rest of your team, and even for yourself, because you're not going to need to write to that repository ever again, hopefully. And then after you've done that, now you're sure that you have the latest and there's nothing that's going to get added after you start the process. Now, the second step is you want to clone that repository using a very special command, git clone -- mirror, and then the repository URL. So what -- mirror does is it basically tells it, I want to mirror what's on the server on my local. So grab all the branches, grab all the tags, grab all that information and have it locally, because I'm going to push it to a new repository. And then a very similar command, but now git push -- mirror, and then the new repository URL. So that's going to push all that information you downloaded locally onto the new repository. And it's going to have all that information. Now, the pull requests won't be moved, but the branches will still be there. So any pull request that was on the old system will have to be recreated. And luckily, it's easy to recreate a pull request. You can just click new pull request and choose the branch, and that's it. And then you need to see if you have any submodules referencing this repository from the document that you created at the first step. And then you update those submodules by going to the Git folder in the .submodule file and make sure that it has the right links. And if you do have some modules, unfortunately, you're going to have to tell your team to do those changes manually, or they're going to have to just reclone and make sure that they have latest. And then you're in that document, you obviously also listed if your continuous integrations has references to the old repository URL, you're going to have to update those as well. And make sure if you have tests in another repository that's pulling your code down, you need to update that as well. Now, the repository settings are not going to be migrated. Say you're going from GitHub to GitLab or whatever, there are branch protection rules on GitHub. Now those don't move automatically. You're going to have to find a way to move those and find an equivalent to GitLab and do that. And then in the end, do not delete the source repository. You want to rename that. And after a week, rename it. Do not rename it right away because something might still be connecting to it. And you don't want everyone to wake up the next day and find that things are broken. Now find a less busy day and rename it a week later. And then if something breaks, you're going to know how to fix it. Just change the URL. And then after 2 weeks, you're going to be sure, okay, everything's fine. Nothing's using that old repository. Let me finally delete it. And you're done.
Nice. That's very thorough explanation. Thanks, Shereef. So before you mentioned, getting into bad states in, with Git, can you explain some of the best practices and strategies that one can follow to kind of avoid getting themselves in these situations?
Yeah, sure. So I'm going to start off by saying that one of the very complicated, or at least a little complicated for newbies in Git, is rebasing. What rebasing does is basically it rewrites the history so that your commit is always at the latest of the base branch. And it keeps the commits clean and doesn't add that merge commit, but then it's rewriting history, and rewriting history can lead to loss of code or can leave you in a bad state locally. And if you're just starting out with Git, you probably want to stay away from rebasing. If you join the team that is already rebasing, unfortunately, and they have strict rules about that, then it's going to get you some time to learn. But here's some tips to help you with that. So if you're rebasing and you get a merge conflict and your GUI or you do not notice the message in the console, you're going to end up with something called a detached head. What that means basically is that you're not in a specific branch right now. You're in intermediate state between the code that you were at and the change that the branch that you want to end up in. And basically, your friend is a command called git status. When you call git status, it usually tells you which branch you're on, whether you're up to date with the remote of that branch or not, and whether you have local changes or not. Now, when you run git status, if it doesn't tell you the branch name and it says merge head or something like that, then you know that you're in that detached state. And you can basically get out of that state and go back to what you were, depending on if you were merging, then it's going to be git merge abort. If you were rebasing, then it's going to be git rebase abort. If you were cherry picking, it's going to be git cherry pick abort. But the idea here is that you don't want to abort, you want to fix it. But in order to fix it, you need to know what got you in this state. So probably use the history command if you're using Linux, or scroll up if you're using Windows and find out what are the commands that you ran to get there, or what did your GUI execute to get you there, and repeat the same commands, but then you know how you got here. And if you got some merge conflicts, then you need to fix them. Usually what I do, if I don't know what happened to get me to get that merge conflict to happen, is I look at the commit hash that I'm conflicting with and the commit hash that I made, and I open those two in the browser, and I see the changes from this side so I can understand them. And then I see the changes from that side, and then I can understand them. And as a developer, you can understand both of the changes, and if you don't, just speak to the person that made the change so you can be sure. Now, after you're sure you understand the logic, you need to now merge them, and not in Git terms. In human terms, you need to find out what they're doing and what you're doing, and then collaborate with them, or on your own, if you're sure, make sure that you include both change set in the same file and that you're not breaking things. And obviously, the tests are going to run after that and make sure that everything's fine, but you got to do your due diligence. And that's basically how you resolve a merge commit. Now, another thing that modifies the history is the git commit amend command. So if you've already pushed and you go to amend, what's going to happen is now you took that last commit and you changed it. So now there's a commit on the remote that you don't have locally, even though it's the same commit you have locally that you amended, but Git will not recognize that. It's a new commit up there. And when you push, it's going to tell you, no, I can't push. And that could get you in a bit of a pickle. And I do not recommend, if you're starting out, to push with force. Pushing with force is the primary way how you delete your code or your teammates' code. So do not use it unless you really know what you're doing. There's one last tip. It is harder for some teams to do. Now, if you're in a pickle and the pickle is that there's a bug and you don't know who introduced the bug, there is a git command for that. It's called git bisect. Now, git bisect needs some prerequisites. You need to know a command that you run that will tell you whether the code is broken or not. In my case, that's the unit test command. I find the unit test that broke when that code broke, and then I do git bisect. Git bisect will pick a commit and tell me, okay, run your command and find out if this commit is good or bad. You run the bisect command and then you run your command and tell it, okay, this commit is good, this commit is bad, this commit is good, and then it will narrow down the exact commit where things broke. And once you find out, you can either revert it or fix forward, but now you know how things broke.
Awesome, Shereef. So just a reminder for those in the audience, there's a chat in Discord, and feel free to put your questions if you have them. So went through a lot of different features, Shereef, but do you have any features of Git that you feel are underutilized that have made you a better developer?
Definitely. So sometimes when I'm working on a feature, I'm being a little bit careless with my commit messages, and then I look at my commit log before I push, and I find that now that I've made all the changes, I want to change how I committed things. There's this command called interactive rebase, and basically what you do is you tell it, hey, I want to rebase the commits between this commit and that commit. And what's going to happen is that it's going to give you a text editor and it's going to ask you what you want to do with each commit. Now you can change the commit message. You can actually squash multiple commits. You can reorder the commits if you like. And then at the end, you have done all of this with one command and a very short time. The alternative is really messy, and I wouldn't recommend like doing the alternative, which is like resetting and cherry picking and doing a bunch of things if you're a beginner anyways. But yeah, interactive rebase have saved me a lot of time over the years. And now GitHub Desktop actually has lots of the similar features in a GUI. And it's the first GUI that actually has something very similar. And I've been using it for a year for stuff like that, and it's really helpful. Now, another underutilized feature is actually staging parts of a file. So staging is basically saying, I want to commit this file, so let's stage it so I can type a commit message and then check it in. You can actually stage a specific line in that file. Let's say you have a task, and that task says to add a new button to this screen. But while adding a new button, you actually fixed the CSS for another button. So instead of having one commit that says, I fixed this button CSS and added this button, you can go ahead and stage a specific line. Now, I've never done this from the command line. I don't know if it's supported on the command line, but it's supported in GitHub Desktop. It's supported in VS Code. Like on the left of the editor, you'll find the green line or the red line, whether you edit or delete it. When you press that, there's actually a plus sign that you can stage this specific line. And then after you stage the CSS changes for fixing the button, you can make that style commit and say, oh, I fixed this button style. And then you commit the rest and say, okay, I added this button. So that's another feature that's really nice and helps you keep your commits nice and clean. Another one is the bisect, which I already mentioned. But basically, it helps you identify the commits that introduce the bug by performing a binary search. And Git hooks is one other feature that I see lots of people not using. Now, let's say you have a specific rule about having your commits messages in a specific way. You can have a pre-commit hook that's going to say, oh, here's the message that they're trying to commit with. Let me review it. And then if the script has feedback, the pre-commit script is going to error out and tell them that feedback so that they can have a correct message. Now, there are tools that does this for you. There is commitlint on NPM, and so you can use a tool like that. And then you can use static code analysis like linting, and you can have that also done on a pre-commit. There are a lot of things that you can do with hooks, and it's really useful, and lots of people don't use them, so that makes me sad. And finally, submodules. If you have lots of things that are related, and you want to make sure that you always have the correct versions of those dependencies, for example, that language does not have a package manager, so you can't really publish that on NPM, or you don't want to deal with private NPM packages or private NuGet packages because that's a little bit of a pain. You can always use submodules. You can have another Git repository live in a subfolder of your Git repository, and Git will help you keep things up to date. But you always gotta weigh the pros and cons and see what's the best for your team, and then you can decide.
Nice, Shereef. Yeah, I had never heard, been working with Git for 10 years now, and I've never heard that you could stage individual lines. That's amazing. I'm going to have to check that out. We do have a question from the audience. So someone who wants to know about the importance of Git in CI/CD or continuous integration, continuous deployment pipelines.
So that's a really good question. Now, there are different levels of where you can have Git enforce things for you. Now, you definitely can do all the linting stuff before you push, and then after you push, you can lint that specific commit hash. Now, along the line, you need to make sure that you are building the app and making the artifact of the built app for that commit hash, and then testing that commit hash. And the commit hash basically is a unique alphanumeric string that is specific to this state of the code. And so you always want to make sure that it's staying consistent from the moment you pushed it until the moment you released it. So basically the steps are you commit and push, your unit tests run for that same commit hash. So you know unit tests ran for that hash and that code is safe. And then you want to build the application and you create that artifact with that commit hash, so you know that this artifact already went through unit test and it's safe. And then you want to do end-to-end testing, deploy it and do end-to-end testing, and it's that same commit hash. And finally, you want to deploy it to production with that same artifact that you created a few steps ago, so you know that this specific state of the code has been linted, it has been unit tested, it has been end-to-end tested, and then it went on production after all of these steps, so you can have the peace of mind that this was like vetted over and over again. And as long as it has that same Git hash throughout the process, there's no doubt in your mind that anything changed with it.
Yeah, it's a nice summary, Shereef. So I think that concludes today's episode. I really appreciate you, Shereef, joining us. It's been a real pleasure to talk to you about Git. And for those in the audience, we're always looking for new speakers that have different areas of expertise and different things they're passionate about. So if you're interested in speaking, we'd love to hear from you. It was a great conversation. You all have a good day.
And thank you so much for having me, Travis. And I want to say that all that I said about the pipeline, probably Travis and Tom from the audience taught me. So they're really good at what they're doing. Thank you, Travis.
Yes. And that being said, Shereef is way better with Git than either Tom or I too. So yeah. All right. You all have a great one.